talk about electric circuits. Electric circuits, we represent them with symbols. A battery is a short line. This is a short line and a long line. Sometimes you can have more. This would be 2 cells. A battery made of 2 cells. This is a battery made of 3 cells. Normally I will just draw 1 in my circuits. A wire is just a straight line. A resistor is something that takes out energy out of the circuit, squiggly line. A lamp is a circle, and inside is a little like light bulb. A motor is a circle with an M and a switch. There's a closed switch. And there's an open one. Okay. These 3 right here are things that take energy out of a circuit, and a general term for them are loads. So if you see this word, you'll know that it's basically anything in a circuit that takes energy out of the circuit. A couple of laws around circuits. Conservation of energy. All the energy gained by electrons in one complete path of a circuit must be lost by the electrons before the path is completed. So if I have a 9-volt battery and it's supplying 9 volts of potential difference to the circuit, the loads in that circuit will use up all 9 volts. And if there are no loads in that circuit, the wire itself will take up that energy and it would start to heat up. The law of conservation of charge. The number of electrons in a circuit is constant. Makes sense. They don't group up together at any point in the circuit, so they're spread out evenly. Now the real topic of the video, Kirchoff's laws. He was a German physicist. He studied circuits. He came up with a couple of laws. First one, the voltage law. So, have you ever gone to the mall with your parents? They give you some money and they say, meet me back here in 1 hour. And when you meet up with them an hour later, what did they say to you? What did they want? They wanted the change. That money you didn't spend, they wanted back. The next time you went to the mall, they gave you some money and said, meet back here in an hour. What did you do? You spent every penny. If you have to just give it back, you're going to spend it all, right? So I call this the shopping rule. If mom gives you some money, you will spend it all before you go back to meet her. So let's do a couple of examples of this rule in action. The battery is supplying 10 volts of potential difference. So your mom gave you $10. How much are you going to spend in this one store? If that's the only store you go in as you walk through the mall and get back to her. Mom gave you $10. You go in one store. How much are you going to spend in that store? 10 volts. Let's do this one. Mom gave you 10 volts. You spent $3 in this store. How much are you going to spend in this store before you go back to see your mom? You're going to spend 7 volts. Mom gives me $10. Now I don't have all day. I have to get back to see my mom, so I have to take one loop and get back to my mom as soon as possible. So I'm either going to go this way or I'm going to go this way back to mom. I am not going to go this way and circle back around and do all sorts of weird circles. I'm going to do one loop and go back to mom. So mom gave me $10. I decide I'm going to go this way through the mall. How much am I going to spend here? I'm going to spend all 10. However, if Mom gave me $10 and I decide to go this way through the mall before I go meet up with Mom, I'm taking the long way around, how much am I going to spend here? 10 volts. Yes, 10 will be spent here, 10 will be spent here. Not 5 and 5, it's a very, very common mistake. 10 and 10. Next one, Mom gave me 10, I spend 2 here. How much will I spend in that store before I go back to see my Mom? I'm going to spend 8 volts. Mom gives me 10, I spend 2 here, I spend 5 here. How much am I going to spend here? 3 volts. Notice that 8 and 8 on both different paths. That's the voltage law, or what I call is the shopping rule. There's also a Kirchoff's law about current. At any junction point in an electric circuit, the total electric current into the junction is equal to the total current out of the junction. I call this the car rule. So I have 6 cars traveling down this wire. How many cars will travel down this wire? 6. Was there a turn? Can they go up? Can they go this way? No, there's only one road. It follows this path here. Every single point on this path will have a current of 6 amps. I've got a battery. I have 7 cars going down this road. 2 decide to go this way. How many will go this way? 5 cars will go that way. So I call this the car rule. Okay? And we'll need these 2 rules as we move ahead attempting to analyze circuits more completely.